So up here I also wrote the conditional, so it's kind of easier. If H, the hypothesis, then C, the conclusion. So if the hypothesis happens, then we get the conclusion. So what comes right after the if?
Then. Well,
Which part?
contains the hypothesis. Then it contains the conclusion.
Right. If contains the, what did you say, Cameron?
Contains the hypothesis.
Hypothesis. If hypothesis, then contains a conclusion. So, here's an example of a conditional statement in if-then form. If it rains, then the football game will be canceled. So which part is my hypothesis?
If it rains.
Which part?
If it rains.
It rains, right? This is my hypothesis. It follows my if. So which part's my conclusion then?
The game will be canceled.
Right, this football game will be canceled. So a conditional statement has the two parts. Our if part, which is talking about the hypothesis. The then part, which is talking about the conclusion. If this happens, then we get our conclusion. That's why it's similar to cause and effect. Not exactly like it, but it's similar. If something happens, then this is the result. So we're going to write conditional statements in our if-then form. So, looking at the first statement first. All birds have feathers. I want you to write this down. All birds have feathers. Before we write it in if-then form, we need to identify which part's the hypothesis and which part's the conclusion. You need to write this down. So who can tell me, in this sentence, in this statement, all birds have feathers, which one do we think is the hypothesis?
They have feathers.
Is the hypothesis?
I think all birds. All birds.
All birds. So all birds is going to be my hypothesis. So then which part is going to be the conclusion?
Feathers.
Have feathers. Now, when we write an if-then form, we can add words into it. Because if I just put if birds have, then have feathers, that doesn't make sense, does it? So we add words into it so that it does make sense. So how can I write that hypothesis part? Does anyone have any idea? You think?
If there are birds, then they have feathers.
Perfect. You said if there are birds, correct?
Yeah.
If there are birds, everybody agrees that's our hypothesis. We just added a few words. If there are birds, then they have feathers. Our hypothesis is right after the if. Conclusion is right after the have feathers. Write that in if-then form. So now we're looking at the second one. Two angles are supplementary if they are a linear pair. Now this one is a little different, but they give us a key word in it that'll help us identify which part is the hypothesis. Does anybody see that? Tanner, you see it?
If.
It has if in there for us, right? So which part is going to be our hypothesis?
Oh, linear pair.
Linear pair. So I want you guys to do the second and third one. Write them in if-then form, and then compare with people so you can see if you guys are getting the same thing. want to be a line, what are a linear pair? What makes a points make a linear pair? What do we talk about makes the linear pair? What are we talking about? So if you want, you can put if two angles are linear pair. Then, yep, you can use. Yep, you can use words from the beginning. You just need to make sure you have the hypothesis and conclusion in the correct spot. I need somebody to go up and write number 2 for me, please. James, you got it?
Sure.
So if I were to say for number 3,
They want to
if
be
you
there,
like,
like, yeah.
if you
That's
multiply
fine.
2 by 3,
Now, notice in number 3, you can actually
then
write
it's equal
either
to
way.
1. Can I do that for my first?
I would accept 3 either way as long as they have the 2 words I'm looking for.
Yes.
There's the x equals
Okay, so we
negative
should
3
have
part,
it
right?
right.
Yeah.
And
We
then
need
there's
an
the
if then,
2x
right?
plus 7.
First, we need an
I just say
If 3x
This one
equals
kind of
whatever,
is
if x equals negative 3,
1 equals 7.
right, because of this.
well, I just say if x
So
equals
that's our
negative
hypothesis.
That's 4.
3, then 2
Then
times
of course
x plus
gonna be
7
our-
equals negative 4.
Yeah, yeah.
Okay. Yeah.
So now we just need to
Or that
rewrite
one,
it.
you probably say the other way around. If 2x plus 7 equals negative 1, then x equals negative 3.
Did you get it? Is that all right? Well, which one? What did we say? Which one would be our hypothesis? Oh. But remember, there's a key word in here that helps us. I need somebody to go up for number 3 too, please. Quick, guy. Right, so there's our key word, right? The hypothesis is right after it. So how are we going to rewrite this in our if then one? What part is right after our if? So write H above what's going to be the hypothesis, so you know which way to write. What did we say was after our if, right?
Well, I guess you just wrote, if you were to multiply 2x plus 7,
Yeah.
then you will equal
We're going to write that in our if. Okay, so we said that here's our key word in our statement if. So that tells us that this is going to be our hypothesis. So we need to write that first. If they are a linear pair, then they have 2 supplementary angles. Then the 2 angles are supplementary. You can also put the 2 angles up front and say, if 2 angles are a linear pair, then they are supplementary. You can leave that 2 angle in front because we're talking about the 2 angles. Just the linear pair is our hypothesis, supplementary is our conclusion. Now this one, we can actually write it either way. We can. If 2x plus 7 equals 1, then we agree that x equals negative 3, right? So we can write it this way, we can also flip it. If x equals negative 3, then 2x plus 7 equals 1. That one we can write either way. We just have to remember that if hypothesis, then the what?
Conclusion.
Then the what? Conclusion, right? Everybody should have that. If what?
Hypothesis.
If,
Hypothesis.
then,
Conclusion.
okay, thank you. Now, we have this word called the negation. You need to write this down too. The negation. When you think of negation, what words run through your mind?
Negative.
Negative, right? Negation, negative. Anything else? Negate. So we think of negative. Well, the negation is negative. It's the opposite of the original statement. The opposite of our conditional statements. So negative, we think opposite. Negation is the opposite of our statement. So if we have our statement up there, the ball is red. How are we going to negate that? How are we going to use the opposite of that?
It's not true.
Right. What word did you add?
Not.
Not. Exactly. So we're going to write the ball is not red. So which word are we using when we're negating things?
No or not.
Not, right? The ball is not red. Now this one's a little different, right? Not's already in that statement.
Their cat is black.
If the cat is not black, how do we negate it to be the opposite of that?
The cat is black.
The cat is black. Good. The cat is black.
Where's Mr. Negative?
Mr. Negative. Negation
maybe
is
not
Mr.
Mr.
Negative.
Or Mrs.
Or,
Not.
no, Mr. Negative. So, we need to know that the negation refers to which word are we using?
Not.
Not, right? Okay, so this is important because we create two related statements to the conditional. But first, just like conjectures, we can prove that they're true or false. So, what do we need to use in order to prove that something's false? What's that word we use? What? We have to use a counterexample. So, I'm looking at this first statement. Can somebody read that first statement for me? Right under true or false, that first statement.
True or false. Supplementary angles are always linear pairs.
So, think about this. Supplementary angles are always linear pairs. Think about this. True or false? I want you putting your thumbs up if it's true, thumbs down if you think it's false.
I have two.
Supplementary angles are always linear pairs. Thumbs up, true, thumbs down, false. Everybody's need to have something.
Double positive equals a negative.
Supplementary angles are always false. So why do we think it's true? Carson, what are you thinking is true? Why do you think it's true?
What? No, double positive equals negative.
Okay, who said it was true? Why do you think it's true, Skylar?
Because you're making a line. A line is 180.
Okay, so we're making 180. Okay.
Supplementary.
So now why do we think it's false, Megan?
Because sometimes supplementary angles are not always linear pairs because they're not always connected.
Right? Everybody hear that? Supplementary angles, do they always have to be adjacent or connected to each other? No. Right? So this is actually false. Supplementary angles are not always linear pairs because...
I thought you were talking about the second one.
No, we're talking... first one. Right? We're talking about the first one. So if I wanted a counterexample, remember yesterday we did one just like this. What am I going to create?
Create two adjacent. Or not.
Two adjacent, like.
Adjacent. Is that going to prove this is
No,
false?
not adjacent.
Not adjacent, right? So I'm going to need to create my
Something that
90
adds up to 180.
Right, exactly. I have my A, B, C, and my D, E, F. Everybody agree?
I got a question.
Everybody agree that those are supplementary angles? Do they add up to 180?
Yeah.
Are they a linear pair? Those are a linear pair?
No. That's what we're trying to prove.
Right, we're trying to prove that those aren't a linear pair, right?
Oh, wrong question too.
We're on one. I'm giving a counterexample for number one, right?
Well, that's the wrong kind of thing.
So those aren't a linear pair, so that's why that's a counterexample for that.
Yeah.
Right? Okay, number 2 and 3, I want you guys on your own to decide true or false. Number 2 and 3, decide if they're true or false.
You just put over
This question was on the first
Doesn't know how to do it.
problem of the day. I think it was,
Learn.
Kaylin, do we keep it up?
that's false.
Yeah, like the woke up.
Which one? Linear
What do you
pairs
think?
are always supplementary. Draw me a linear
Second one.
pair.
Isn't no linear pair, that's
True.
just,
Now
they're
you're on the
same
third.
thing.
You got a line and
I
then
think the second one is
split
false.
up that line, split up that line, and then those two angles right here, that makes a linear pair, right? Are they always supplementary?
Linear pair, what's a linear pair?
Supplementary means they add up to 180, right?
Connected, what
So
about
do those add up to 180?
linear pair doesn't?
But you can also make one like this.
No, that would be a linear pair then.
Doesn't linear pair have to be touching?
Yeah. For it to be a linear pair,
Right?
it
Okay,
has
so
to be
that's the number
supplementary,
one,
because that's
right?
basically the definition of a linear pair. It means they make a straight line.
No, those are
Yeah,
supplements, right?
I would say
But that
number two
one
is
doesn't
definitely
linear
true,
pair
because
have
linear
to add up
pairs
to 180 on
have
the
to add
same
up to
line?
180
Right.
because they're on the
So,
same line.
are all linear pairs supplemented then?
So then how about the third
Yeah,
one?
so that's gonna be-
Measure of angle A is 99
True.
and angle A is
Good.
obtuse.
True?
But is it up to like greater
The
than
second one?
99.
False.
Greater than 90.
And then
There's
breach.
90 or is it 90?
So it'd be 100.
So what is a linear pair? What do you give the second one?
So if,
What is a linear pair?
no, but if the measure of angle A is 99, then his angle A is
Right?
an
So they're gonna add up to what?
Why do you think not?
They're on the same line, 180, right?
The measure of angle A is bigger than 90, right?
Taking that 9 minus 180.
No, don't do
180. So if we have a linear pair.
99 is already.
Oh, it's not a linear. I thought it was a linear pair.
Yeah, no, we're ignoring the linear pair part. Now we're just saying, if I got,
True, right? Two? Yep.
So number 3 is up to, yes.
Okay, so,
true.
number two. First of all, I want thumbs up, true, thumbs down, false. Thumbs up, true, thumbs down, false. Davis, you got number two. We all agree? Right. What is a linear pair?
Same
A
line.
line.
Two angles on the same line.
Okay, so they add up to what?
180.
So this is going to add up to 180, correct? Everybody agrees?
Yeah.
All linear pairs, correct?
They have to.
Now, are all linear pairs always going to be supplementary? What's supplementary?
Add up to 1.
Something that adds up to.
Two angles that add to 180. So are these always going to be supplementary?
Yeah.
Yeah, right? That's true. Notice that these, we just flipped around, right?
Yeah.
I switched the linear pair and supplementary, but this one was false and this one was true. That's going to happen, right? Now, if the measure of an angle is 99 degrees, then that angle's obtuse. True or false?
True.
Why is it true? What are obtuse angles? What's the measure of obtuse angles?
Over 90 degrees.
90 but less than 180. And is that more than 90 but less than 180?
Yep.
Yep.
Yep, perfect, good. So we didn't need any counterexamples for those two. Now, these you're going to need to remember the difference between conditionals, converse, inverse. Yep, you need them written down. So, our conditional, we said was if our hypothesis, then our conclusion. Our conditional was if our hypothesis, then our conclusion. Now, if we just look at our converse, the converse of a statement, we just exchange the hypothesis and conclusion. We just flip them. So now we're changing into if the conclusion, then the hypothesis. We flip them. So if I'm giving you the conditional statement, if I live in Van Meter, then I live in Iowa, I want you to think about how I can write that as the converse of that conditional statement. Remember, I'm flipping the hypothesis and conclusion. Can somebody raise your hand and tell me what you think the converse is going to be? Leah, you think you got it?
If I didn't live in Iowa,
So careful.
That'd be
We're just
inverse.
flip. You're good. So now we're just flip them. You're good. We just flip them. So my hypothesis in that conditional statement is what?
If I,
If I live in Van Meter, right?
yeah,
And the conclusion is what?
then I live in Iowa.
Okay. So if we're wanting the converse, we just flip them, right?
So if I live in Iowa, I don't know.
Yep.
If I live in Iowa, then I live in Van Meter.
Good, yep, that's all the converse is. We just flip the hypothesis and conclusion. So, like Cameron was saying, the converse is just, if I live in Iowa, then I live in Van Meter. Perfect. Then we get the inverse. And what did we say that the negation was? What word do we use to negate it? Skylar?
None.
What word do we use to negate it?
No.
Anyone, what word do we add in?
Not.
Not. Right? Negation, negative, we add not. So, with the inverse, we do not change around the hypothesis and conclusion in the conditional statement. All we're doing is negating the hypothesis and negating the conclusion. Or adding not to the hypothesis, not to the conclusion. Do you think you got what the inverse is?
If I do not live in Van Meter, then I do not live in Iowa.
Yep, perfect. All we're doing is add not. Now notice he add do not live. You can add words, remember. You need to add words for it to make sense. If I live not in Iowa, then I live not in Van Meter.
Okay, instead of
Sounds a little silly.
putting not, keep it don't.
Don't. Yeah, I want you to get in a habit of using not, but I did put don't. So it is, just like Skylar said, if I don't live in Van Meter, then I don't live in Iowa. Now, with some people around you, I want you to discuss if these three statements, each one is true or false. So, discuss with people. First of all, the conditional statement, true or false.